guys, this is Maya Alochi, and in this video we will learn more about the structure of alkanes, and we will also learn how to name alkanes using the Iupac system. So let's get started. Alkanes are molecules that are composed of carbons and hydrogens only, and they have single carbon-carbon bonds. These molecules are considered to be saturated because of their single carbon-carbon bonds. Now we're going to go ahead and learn how to go from structural formula to line angle formula. So in the structural formula, you can see that we have showed all the carbons and all of the hydrogens. Our structural formula here has 4 carbons in a line. And then when we go to the line angle formula, it looks like a zigzag. Every time you see end of the line or you see 2 lines coming together, that represents a carbon. So let's go ahead and show all the carbons. So there is a carbon here at the end of the line, a carbon here where the 2 lines are coming together, another carbon here, and another carbon here. So this line angle formula represents 4 carbons. And also, it is important to know that the carbons on the line angle formula have hydrogens, but these hydrogens are not shown. So the hydrogens on the carbons in the line angle formula are not shown. How do we know how many each carbon has? We just have to remember that every carbon wants to have 4 bonds. So, for example, this carbon here has 1 bond, and that means it's missing 3 bonds, and those are the 3 bonds to the hydrogens. So that means that it has 3 hydrogens that are not shown, which we can see here on this carbon, it has 3 hydrogens. This carbon has 2 bonds. Remember, it wants to have 4 bonds, so that means that there are 2 more hydrogens here that are not shown. So this molecule on the left, we see it has 4 carbons in a line, and on the right we see its line angle formula, where we see also 4 carbons drawn like a zigzag, and the hydrogens are not shown. Next, let's go ahead and learn the nomenclature of alkanes and the Iupac system. Nomenclature means naming, so we're going to learn how to name alkanes. First, in order to name alkanes, we have to find the longest continuous carbon chain. And this carbon chain can be vertical, horizontal. It can be first horizontal and then go up, or it can go diagonally. And this chain is called the parent chain. And if we have an alkane, which means all single bonds, it will end in ane. Another thing that we have to memorize is we have to memorize the prefixes for the number of carbons in our parent chain. So for example, if we have 1 carbon, it's meth, 2 carbons is eth, and so on, as is written here. So let's go ahead and look at some of these examples and find the longest parent chain. Let's go ahead and look here. We can go 1, 2, 3, 4, 5. So this would be a 5 carbon chain. Let's see if we can come up with anything that is longer. We can go 1, 2, 3, 4. But instead of going this way, we can go here 5 and 6. So we can see that this chain must be the longest parent chain. And because it has 6 carbons on it, 6 is hex. So my parent chain will be called hexane because we're dealing with alkanes. The ending is ane. So again, what we did here is we counted the carbons to find our longest continuous carbon chain. In this case, we had 6 carbons, so my parent name should be hexane. What about here? Let's try to number in all the different ways. We could go horizontally, 1, 2, 3, 4. What else could we do? We could go 1, 2, 3, 4, 5. That's longer. So my longest chain will be here. Let's go ahead and number it. 1, 2, 3, 4, 5. And because my longest continuous carbon chain has 5 carbons, that means it has a prefix of pent. So my parent chain will be called pentane. So the first thing that we always have to do when naming our molecules is to find the longest continuous carbon chain and to also remember the prefixes that goes with the number of carbons. Now let's look at the second step. Second, we have to number our parent chain from the end closest to the first substituent. Substituents are groups that are not on the parent chain, that are coming off of the parent chain. So let's go ahead and look here. Where is our parent chain? Where is the longest carbon chain? We have 1, 2, 3, 4. That's too short. 1, 2, 3, 4, 5. So that must be our parent chain. And I'm going to go ahead and I'm going to highlight it. So my parent chain is here. And so where are my substituents? That's groups that are coming off of the parent chain. So this must be one and this must be another one. It says that we have to number from the end closest to the first substituent. If I number from the left, I will say 1, 2. So my substituent will be on carbon number 2. If I number from this end, we will number 1, 2, 3. So my substituent will have a number 3. 1, 2. This one is closer, so I have to number from the left. 1, 2, 3, 4, and 5. It's very important to know which way to number, so it's very important. The second rule is very important that we have to number from the end closest to the first substituent. Next, if there are multiple substituents in equivalent positions from both ends, so if multiple substituents could be, for example, number 2 or number 3, we have to start numbering from the end that has the substituent with the lowest alphabetical order. So let's go ahead and take a look. My parent chain here, my longest chain will be this one, or I could do this one, it does not matter. But let me make it easy and go this way. So that's my longest continuous carbon chain, and these are my substituents. Now I can see that if I number from the left, it's 1, 2, 3. This group is on carbon 3. If I number from the right, 1, 2, 3. This group is also on the carbon 3. So how do I distinguish which one wins? So it's alphabetical order. What is this group called? It's 1 carbon. So if we go to our prefixes, 1 carbon has a prefix of math. And the second group has 2 carbons, 1, 2. And 2 carbons have a prefix of F. So who is going first alphabetically, M or E? E goes first, so it is the winner. And I have to number closest to this substituent. So I have to number this way. 1, 2, 3, 4, 5, 6, and 7. And by the way we will name our carbon substituents, it will be the prefix ending in -il. So this had 1 carbon, it's math-il, methyl. This had 2 carbons, it's eth-il, ethyl. So this is a methyl substituent and this is an ethyl. And this is what we're going to learn next. Once we have numbered our parent chain, it is time to name the substituents, which are the groups that come off the parent chain. If we have alkyl substituents, like I said before, which are substituents that contain carbons, then we're going to use the prefix ending in -il. So for example, if it's 1 carbon coming off, it's methyl. 2 carbons, ethyl. 3 carbons is propyl. I also wrote some of the things that you might have to memorize, which are called common names. So this substituent that looks like a V, that's isopropyl. Propyl is 3 carbons, 1, 2, 3, and it's connected to the parent chain on the second carbon, so it's called isopropyl. 4 carbon substituent is butyl. If we have something that looks like a cross, that's called third butyl. If we have this substituent, it's called sec-butyl, and if we have 5 carbons coming off, it's pentyl. If there are multiple substituents with the same name, we have to use prefixes di, tri, and tetra. So let's go ahead and take a look. Again, we have to go step by step. What is step 1? Find the longest parent chain. I go 1, 2, 3, 4. 1, 2, 3, 4. So the longest parent chain must be my 4-carbon parent chain. I'm going to go like this. Next, I have to think which number to number from. So 1, 2, 1, 2. From the left, we're getting substituents on carbon 2, and from the right also on carbon 2. But from the left, there are more substituents on carbon 2. So I should number from the left. 1, 2, 3, and 4. Since my parent chain has 4 carbons, 4, we go to the prefixes. 4 is bute. So my parent chain must have a prefix bute. Butane, because this is alkane, all single bonds. Next, what we're going to do is we're going to look at the substituents. There's one substituent here, another here, and another here. What are they called? This is called methyl because it has 1 carbon. This is also called methyl because it has 1 carbon. And this is called methyl as well. So we have 3 methyl groups. When we have the same substituents, for example, 3 methyl groups, we have to use prefixes di, tri, or tetra. So here we have 3 of them. Di is for 2, tri is for 3, and tetra is for 4. We have 3 of them, so it will be trimethyl. And we also have to signify where are our substituents located. We have 1 methyl on carbon 2, another methyl on carbon 2, and another methyl on carbon 3. So our name will be 2, 2, 3. We specify where are our substituents. They're on carbon 2, another one on carbon 2, and another one on carbon 3. Trimethyl butane.